Hello and welcome to another video in which we'll be practicing Barrow's theorem and specifically the method of finding the area between two functions that do intersect between 2 points. So the area between those 2 points. So let's start off with an exercise. Well, our f of x is going to be equal to x squared and our g of x is going to be equal to 4x minus x squared. Our formula is b upper limit, a lower limit, f of x minus g of x dx, where obviously b is greater than a, f of x is greater than g of x in between the points a and b, not including a and b, and that a and b are points of intersection between f of x and g of x, of course. So first, let's find our points of intersection. We do this by equaling our both functions. X squared is equal to 4x minus x squared. This is going to be 2x squared. We move this to the other side. Minus 4x equal to 0. We can divide all this by 2 to obtain x squared minus 2x equal to 0. And then this is x times x minus 2 equal to 0. So our two solutions are x equal to 0 and x equal to 2, as this is x equal to 0, 0 times something is 0, and if x is equal to 2, this parenthesis inside here is 0, so whatever times 0 would be equal to 0. So this right here is going to be our a, and this right here is going to be our b. Let's just find which function is greater at these points. We have to find a point in between these, so let's just take 1. For f of x, 1 squared is 1. And for g of x, 4 times 1 minus 1 squared. So 4 times 1, which is 4, minus 1 squared, which is 1. 4 minus 1 is 3. So in this case, our g of x is greater. So we have to write that one first. So we have upper limit 2, lower limit 0. 4x minus x squared minus x squared dx. This is going to be equal to upper limit 2, lower limit 0, minus x squared minus 2x squared plus 4x dx. This is going to be equal to minus 2x squared is going to be equal to minus 2x to the power 3 divided by 3. Obviously, if we derive this is minus 2x to the power 3 multiplying, cancels this out and stays squared, same as here, plus our 4x is basically 2x squared. If we derive this is 2 times 2, 4, and we get rid of this, 4x. And this we will apply to 2 and 0. Obviously, we don't need to apply it to 0, as if we apply it to 0, this will just everything be 0. So let's just apply it to 2. Minus 2 times 2 to the power 3 over 3 plus 2 times 2 squared. 2 times 2 to the power 3 is 2 times 8 over 3. And we are adding, this is a negative, and we are adding 2 times 2 squared, which is 2 times 4. We have here 2 times 8 is 16, so minus 16 over 3 plus 8. We have to turn this 8 into a denominator of 3. So we have minus 16 over 3 plus 8 times 3, 24, 24 over 3. And therefore, minus 16 plus 24 is going to be equal to 8 over 3 units squared. And that is our answer. 8 over 3 units squared is the area between the curve 4x minus x squared and x squared between the two intersection points 0 and 2. Let's practice with another example. F of x is x squared and g of x is 2x minus x squared. So we have here that x squared is equal to 2x minus x squared. This is to find our point of intersection. 2x squared minus 2x equals to 0. So therefore, x squared minus x is equal to 0. So x times x minus 1 is equal to 0, and therefore either our x is equal to 0 or our x is equal to 1. This is our A, and this is B. Let's find which one is greater. Let's take point, let's just say 0.5. 0.5 squared is 0.75, and 2 times 0.5 is 1 minus 0.25 to 1 minus 0.25 is greater than whatever this gave us. So g of x comes first. 2x minus x squared minus x squared dx is going to be equal to minus 2x squared plus 2x dx is going to be equal to minus 2x3 over 3 plus x squared applied to 1 and 0. This is 1 and 0, and this is 1 and 0, of course. And so this is going to be minus 2 times 1 over 3 plus 1 over 2, which is just minus 2 over 3 plus 1, which is 1/3 unit squared. So we have that 1/3 unit squared is the area between x squared and 2x minus x squared for the points of intersection 0 and 1. Thank you for watching. That will be all for today's video, and that will be the conclusion of seeing all the methods of Barrow's theorem and practicing with exercises. In our next video, we're going to be seeing volumes and how we can solve these using integrals as well.